Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome to our NPTEL online certification courses on engineering drawing. We are in module number 2, lecture number 18. We are covering conic sections, especially on special curves. In the last class, we have introduced these special curves, namely cycloid, a spiral, an involute and an helix, and we stopped to learn about this construction in the next class. So, in today's class we are going to learn about a special curve named cycloid. Where do we see these cycloid curves? First of all, we will ask. For example, if you are looking at your bicycle, motor wheels where sprocket and gears are located, or any automobile engineering, machinery, farm machinery, anything you open where gears are predominantly located, these cycloid curves are quite common. These cycloid curves gives better efficiency in mating the gears, so that frictional losses will be bit less compared to any other kind of mating surfaces. They will be bit smooth and transmit power in line with the shaft with very less slip on the surfaces. So, if we are looking at carefully the machine gear where these teeth will be joining with the other teeth, let us look at that part. For example, this blue one is the machine gear. This machine gear might be constructed based on a base pitch circle or pitch circle. So, based on certain radius, for example, if this is the gear, what we are looking at on the right hand side, if this is the center, let us call this one center, from here to somewhere at mean level of this gear, whatever the radius we are going to use and construct a circle, that circle what we call base circle. So, this is that base circle. Above base circle, we have these flanks. So, these are called flank portions. Let us use other color. This one is one of the flank. This is other flank. These flanks on the top side we will see, and also on the bottom side we will see. And if we are looking at this top portion, that flanks are called addendum flanks, and the down ones are called dedendum flanks. And this curve usually constructed by cycloid. For example, on this base circle, let us consider one more circle, this orange one is rolling. If this one is rolling in this direction, let us pick this point, the point P, the curve in which direction it forms or tracks, that is called, we call cycloid. In that part of the circle, above this base circle, up to certain length, we call that as epicycloid, because it is running over another circle. Cycloids for which we usually roll it on a straight line. For these epicycloids on top of that point, and this circle continuously rolling on another circle. Similarly, the bottom of the curve constructed by hypocycloid. For example, there is a line on which this green one is rolling, then part of the curve in which direction it moves, that is what we call this hypocycloid. So, cycloids are quite common for gear construction. Similarly, if we have pendulums, isochronous pendulums, here a pendulum connected by a rope and this rope is going up, the location of this point with the time and the curve along which this point is going up and down. If we are in a position to track, this curves makes cycloids. Similarly, this one also a cycloid. Similarly, if we are looking at arches for architectural point of view, the top portions make cycloid curves. Now, how to construct a cycloid curve geometrically? To do that, first of all, we have to use a generating circle which is rolling on a baseline. Our generating circle is this, and this is rolling on this line base, and then we locate a point P, track this motion of this point P. For that, what we do is divide this entire circle into 12 equal parts. In that way, we make 12 equal parts, and we will name them 1, 2, 3, 4 and so on all the way to. Once that is done, we draw parallel lines to these points 1, 2, 3, 4, 5, 6. So, 1 is going to cut. So, one line, from there we draw a parallel line. Similarly, from point 2 we are going to draw a parallel line, from 3, 4, 5, 6, again from 7, 8 and so on, we repeat all the way to this point P. After that, with using compass, we are going to locate the intersection points of this curve on these horizontal lines. So, after division of this circle, we make 12 equal parts. From 1, 2, 3, 4, 6, we draw horizontal lines. Then the line which is passing through the center, we divide that into equal number of parts from extending these 1, 2, 3, 4, 5 in the perpendicular direction. Pick each one as center, mark an arc on the first line. For example, pick this one, mark an arc on that first line, pick C1, mark an arc, pick C2, mark an arc, C3, mark an arc and so on. Join these things so that it forms a cycloid. Let us look at that procedure step by step using our graph sheet. First, we have to draw a circle of chosen radius and know that 2 pi r distance, draw a horizontal line. So, let us use a generating line, 2 pi r we have to do. Maybe r, let us pick something like 3 centimeters. So, 2 pi r length, 2 into 3.14 into 3 centimeters. So, 8 2, 6 into 3, 24, 6, 7, 8, 18. So, 18.84 number we have to use. Now, at geometry this is always be difficult in terms of choosing it. So, usually we draw something like a nearest number, something like 20 mm or 20 mm, 20 centimeters kind of line, then construct what might be the equivalent radius, use that equivalent radius, construct a circle. So, we will do it in the same way. First of all, let us construct a baseline of 10 units. So, the baseline begins here, ends there, which is 100 millimeters. 100 millimeters is baseline. Let us call that point 1 here and 12. Divide this 100 mm into 12 equal divisions. So, draw a inclined line, divide that into 12 equal divisions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Now, join this point all the way to 12. We have to use go parallelly . Parallelly in this direction, so that we can mark these points. Okay, go carefully. Twelve divisions we have to mark. So, these are the points, mark them as 1, 2, 3, 4, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, I think we made this is 12. Let us use equal number of divisions, so that this length we are going to measure it. So, this length whatever that we are going to make it into 12 equal parts, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, okay, we are right. into 12 points. The notation is this begins with P point all the way to 12. So, let us call this point P 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12 points. That is 100 mm. So, use your calculator to calculate what is the equivalent radius. 2 pi r is equal to 100 mm. So, 100 by 2 by 3.1416, that gives you 15.9 mm. This is the approximate circle what we can use. So, let us first of all mark 15 to 16 mm. So, the least count what we can have is 16 mm in this case. Otherwise, what we can use is take bigger circle, so that we will be in a position to increase that least count and the length also increases. So, use this length okay. Draw a circle from P point divide this circle into 12 equal parts. That means 30 degrees angle is the one what we can use it. So, mark 30, 60, 90, 120, 150, 180. Use our scale to construct join these lines. Similarly, join this 30 degrees line. Join this one also. So, we made 12 divisions. We can have 24 divisions and so on, so that a better curve can be tracked. Now, name them carefully. Always point P somewhere here. So, this line on this, we can now draw this line parallel to that, because the circle is rolling on a line. So, this is the line on which it is going to roll, and these are the centers. Now, draw perpendiculars to this line. This is the line, and to that, passing through these points, construct 1, 2, 3, 4, 5. These lines goes all the way to base. One has to be careful with these construction lines, and it goes all the way to 6. 7, 8, 9, 11, and then 12 line. Let us darken the base. This is the base on which our circle is rolling. These are the center lines. So, C1, C2, C3 and so on, and draw horizontal lines going through these points. Now, this is the curve. Let us mark these points as 1, 2, 3, 4, 5, 6 and so on. So, let us draw few horizontal lines. First one, second one, third one goes there, fourth one also goes in that way, 5 and 7 goes in that way, and 6 also goes in that way. So, on these lines we have to make arcs. So, first of all what we have to do is with compass and circle radius make arcs on the lines with center as C1, C2, C3 and so on. So, first of all this is the radius what we can locate. Now, from C1 make an arc on 1 somewhere there, locate that point. So, the first point is that, second point is that. From C2 locate it on the line 2. So, 1 locate it there, from second point locate a curve here, and third point locate it, and fourth point locate it, fifth point make an arc, now sixth one this. So, let us join these points, first one, second one, third one, 2, 1 somewhere we have lost. So, let us join these points which are going through it. Let us extend that for the seventh one, again goes there, eighth one, on eighth one, 10th one, on to the 10th. So, 7, 8, 9, 10, 10th line is this. So, from 10 make an arc, and 11th one on that, and 12th again comes to that point. This is the way we construct a cycloid. In the next class, we will learn about how to construct spiral and involute. Thank you very much.